Differential and integral operations 3. Perform the line integral on this closed curve dr cross with v, where c is the contour shown below. So this is basically x-axis, this is y-axis, you can see here. And here we have -1 to +1 on the x-axis and -1 to +1 on the y-axis. So this basically defines our y-axis here. All right. Let's move it to the center. And we're going to do this in part A for v0 ex hat. So v vector is v0 ex hat. Now on segment 1, we have to find what dr is. As you can see, we're moving on the y-axis from -1 to +1 on the y-axis. So it's going to be dy ey hat. So on segment 1, our displacement vector dr1 is dy ey hat. And y is changing from -1 to +1. And when we do dr cross v, dr1 cross with vector v here, we have dy ey hat cross product with v0 ex hat. And now we have to remember I hat cross j hat is k hat, or ex hat cross ey hat is ez hat, but ey hat cross ex hat is minus ez hat, using the cyclic permutations. So this is minus v0 dy ez hat. So our integral on the first segment, dr cross product with our vector v, is the integral from -1 to +1, y goes from -1 to +1, minus v0 dy ez hat, and that's going to give us, the dy will give us a y, going from -1 to +1 gives us a factor of 2, minus 2 v0 ez hat for the first segment. Now doing this for the third segment here, we're now going from y equals 1 to y minus 1, but dr vector is the same, dy ey hat. So on the third segment, dr3 is dy ey hat, and this time y goes from 1 to -1, and dr on the third segment cross with our vector v then becomes dy ey hat crossed with v0 ex hat, which is identical to what we did in the first segment, minus v0 dy ez hat. And our integral on the third segment, dr cross with v, is integral from 1 to -1 minus v0 dy ez hat, which will give us plus 2 v0 ez hat. Okay. Now on segments 2 and 4, similarly, I'm moving on the x-axis, so my dr vector is dx ex hat. On 2, I'm moving from +1 to -1, on 4 from -1 to +1. So on these two segments, dr vector is equal to dx ex hat. Now when I look at dr cross with v, I have ex hat cross with ex hat, v0 dx, which is 0. So for both of these integrals, integral over segment 2 and integral over segment 4, my answer is 0. Then I can find the total, which will give me the closed contour integral on the closed contour C, dr cross with V. This is basically the sum over the first segment integral, second segment integral, third segment integral, fourth segment integral, dr cross with V. And my answer for the first segment was minus 2v0, second segment was 0, third segment was 2v0, and fourth segment was 0 in easy hat direction. Therefore, the minus 2v0 and plus 2v0 will cancel. My closed path integral dr cross with V for part A has to be equal to 0. So that's my final answer to part A. Okay, so we were asked to perform the line integral closed path dr cross V in part A for the V vector being V0 Ex hat. Now in segments 2 and 4, since I'm moving on the x-axis, my dr vector is dx Ex hat and Ex hat cross Ex hat is 0. So 2 and 4 give no contributions. 1 and 3 give contributions in opposite directions as dy Ey hat cross with V0 Ex hat. One gives minus 2V0, the other one gives plus 2V0 Ez hat, so the summation is 0. Therefore, the answer, closed path line integral dr cross V for part A is 0.